And I'm live. That is pretty cool. Today is 13th of November 2025, Thursday, and with that, let's begin. So there are a few things that we have to do today. Yes. First of all, the Git branch merging that we were doing yesterday. And yes, I do have a plan as to like how we can do this without messing everything up and shit. Okay, what is this? That would be 2200 minus 100, 110. That would be 2200 minus 110, 2090. I think would be the correct answer for this. And okay, it is, that is good. Okay, what we have to do is first let's RMRF game of life test, right? And copy game of life and copy this like in a recursive fashion. Game of life to game of life backup so that we do not mess stuff up else, and we do have the backup, so that is cool. And if we go into the backup, no shit, that is not the backup, this is the backup. And if we make dot slash, okay, the thing goes to game of life, that is fine. Let's see. Okay, before merging I have to make sure that I have the latest code. Game of life, yep, sync forth, everything is up. That is nice. So what was the latest commit? Latest commit was merging a pull. Sure, I think my friend messed up a little bit. Okay, there's a thing, and shit, he did merge 13 hours ago, like yeah, in the night, but there was shit, he didn't. Yeah, he messed up. There was a commit that he made, and I guess he made that onto some other branch instead of the default one. Okay, let's go there. And yeah, so I do have the latest code, that is very nice. And cd game of life and git pull, I am up to date, so that's nice. And git status, nothing is there. And if we run my game, yeah, everything runs fine. That is nice. Yeah, press D to go into the mode. Yeah, that is nice. So we have to make a few changes. First of all, I'll have to get the code from this remote bro. Git remote add friend https://2/github.com/okay and game of life. That is nice. Git fetch everything. We should have everything. And if we do git branch git no pager branch all. Okay, we do not have friend git remote add friend. Um, why do we not have the git remote add friend? Yes, // github.com game of life. Okay, it already exists. So git no pager remote friend and origin. Okay, so git switch friend dev. Okay, I messed up. Git switch friend dev. Only reference fatal. Only one reference expected. Git branch. Git branch. All. Let's get all the branches. And why do we not have git fetch? Why are you not fetching thing? Okay, slash game of life. This is 11 commits behind the main source, so that is crazy. There are two branches, 78, and here we have how many commits? Yeah, 98. So yeah, 89. 11 commits behind. Yeah, git fetch, git remote, get URL all for friend. Okay, and get remote URL add set add rename add v as in verbose fetch from this and push also to this get full verbose, I guess. What is this? And get upload pack 213 bytes from github.com. My thing already up to date. Get full friend dev. Is that is not okay, but we do have merge conflicts and shared auto merging source helper. Shit, this is trying to rebase enumerating objects, total objects, unpacking objects from this dev to fetch head, dropping this add support for wheel and package already upstream, auto merging source helper and conflict content merge conflict in source helper, and there is a merge conflict in variables and in prediction addiction. Okay, we need to about this about, and what we can do is we can share it. That would be cool. We can manually go to the least common ancestor, get no pager log graph, yeah, the last 28 things, friend dev. We can manually go to this least common ancestor and pull the friend dev thing on here, and yeah, that would be cool. Get switch create dev new. Okay, we are on dev new. Then get reset hard to this. We are now at this thing, right? And get pull from friend dev, and everything is okay. Shit, that is actually pretty cool. Get no pager and don't show us all the branches. Show us just where we are right now, and we are on the Vivo commit, and now we can rebase this commit onto the main one, and that is very cool. Okay, yeah, that is like very actually cool. Okay, so but also let's see, first of all, get no pager all. Okay, we are our head right now is here, and we will rebase the base of this one, which is testament to retardness, and we will put it here at the top, and that would be nice. Git rebase main or git rebase h help. Git rebase help, and okay, we are on rebase. Git rebase. What is the third command? Interactive is something which I guess we should not do. Interactive this. If branch is specified, git rebase will perform an automatic git switch branch before doing anything else. Otherwise, it remains on the current branch. If upstream is not specified, okay. Git rebase onto main. Now there are conflicts, which makes sense. Could not apply this testament to retardness. 7B8891. Okay. Now we are doing git rebase and we are fixing merge conflicts, which is cool. Changes to commit. There is a new file, which is this. That is fine. But there are unmerged paths in source/main.cpp. Let's fix that in our main function. This is the code that we have, and this is all the code in the other function, in the other branch. And yep, we will remove all of this because yes, why not? We'll see if there is any extra function which is not being handled in the function that we have right now running. Okay, we can just delete this. There is nothing special here. Get status, get add all, get status, get commit m, and we'll say edit to do git rebase edit to do to view and edit. Okay, last commit done, which is like the current commit which we have to fix. Testament to retardness and cool. Git rebase continue. And now we have another conflict. Get its status in helper main and variables file, and this one is called added zooming and padding. Okay, and yeah, there is a new file also here, camera.cpp. That is fine. Helper.cpp. What is the problem here? This, my head does not have anything, but this other head has a lot of things which we can just remove. No, we cannot just, there is camera and stuff happening, so we have to handle the camera logic. Hello, how is everything going on? Yo, and yes, here we are trying to merge stuff with each other, and let me show you how the tree looks like, which we are trying to merge. Yeah, uh, this is a commit which was made, which branched off from the main thing at this commit, but since then there have been other commits, and there have been quite a few commits and which have been merged, which branched off and then merged again, and then new commits. And what we are doing is we are taking these three commits and putting them on top of this main head commit. And yeah, that is what we are doing. And right now we are solving merge conflicts. Today I did my first do forces questions in Python. Lol, shit. Yo, I'm also pretty cool. And what is do force? Like code force? Shit. Okay. Okay. Code forces. That is cool. That is cool. Code forces is cool. Helper editing equals false. This is all the code that we have, and this is the merge conflicted code. Right here, user input update help box is just a function declaration. In edit mode, we can remove all of that. Camera. Camera is the stuff that we need to send away. Change grid. int state camera 2D, and where is the camera being used? Get screen to world 2D. Uh, v- shit. Okay, and get mouse position. Shit. We have to update the DD logic. Shit. Shit. Okay. There is a problem, and that is, uh, we applied an algorithm a few days ago, which is DD. Code, yes, my bad. Code forces, bro. When will you get back to CP? Maybe in a while. On 16 there is a contest ICPC which we will be giving. I will be giving, and yes, if you want to join, that would be really cool. Yeah, you can message me on Discord. We will do the thing together. That would be cool. Now I am doing a way too long word. Shit, that's cool. Yes, as a team, that would be cool. Actually, yes, as a team. ICBC, it is on Sunday and it starts at 7 a.m. Yes, and is 5 hours long if I am correct. And we have a problem. The problem is we applied the DDA logic, which takes in the last and the current position of the mouse and draws a line, and whatever the background grid is in the whole game, it figures out which are the cells through which this line goes through and lights up all of those cells. But now we have applied camera logic to this shit. We have applied zoom in and zoom out. There is a function zoom in and zoom out, and how are we going to calculate things with that? Okay, let me see what this function does. Get screen to world 2D, which also takes the camera and the mouse position. Raylib.com cheat sheet. Damn, yes. But I think I should learn from now. I cannot join that event. That is fine. That is fine. So, bro, I will be at home on Sunday. Will you give Friday contest? Nope, I'm not giving Friday contest. I'm searching Friday. Yep. Nope. Not the Friday one. This one. 14. That is Children's Day, so we have to enjoy. And yes, ICPC. This one. 16th. 7 a.m. That is a strange time. 7-5. Shit. Okay, everything is messed up. I think, shit. This function, I think, is going to like do all the maths and give us the correct coordinates. Get screen to world 2D. This one, get screen to world 2D, takes in a vector position and a camera. Get the world space position get the world space position for a 2D camera space screen space position. What does that mean? What does this mean? Get the world space position for a 2D camera space position. Uh, and by the way, the creator of Raylib is my friend on Discord. Like, yes, I sent him a hi wave message and he sent back hi. which is crazy. So yes, he is a real person, and we are friends in Discord, which is cool, like crazy. I don't know why Code Force feels addictive. Not gonna lie, yes, it can feel addictive, and yes, you also have to be really careful because there are like very very good people over there who are like really really good at code forces, and if you start to compare yourself, and yeah, it can just go downhill from there. You will start feeling bad about yourself and stuff. So yeah, be careful out there. uh okay, get a screen to world to be cheat sheet. Nope, nope, nope. Some more PDF, which is the same thing as the cheat sheet. uh and yes, and he comes online from phone. Yeah, Raysan is his name. He comes online. Yes, this is his TP. And yes, he comes online from phone. He has a phone icon in Discord when he comes online, which is funny. In Raylib, the function getScreen is used to convert a point from screen coordinates pixels into the world coordinates based on a 2D camera. Let's break it down clearly. When you use 2D camera in Raylib, instruct the camera can move around, change, zoom, rotate. But when you move the camera like this, your screen pixels where you draw them doesn't directly match your game world coordinates anymore. That is why screen to 2D comes in. It lets you translate a pixel position like where your mouse is into the actual coordinates in your game world, that the camera is showing. Shit, okay, this is kind of confusing. What it returns a 2D vector, the same point, but expressed in world coordinates, meaning the coordinate system of your game object before camera transformation. So that is good. That is very good. 2D camera, we create a camera, target, offset, zoom, and get mouse position. Give that function to the camera. Now, okay, that is good. So the only change that we have to do is we have to pass. Oh shit, okay, the thread on which okay, I cannot show the game of life test backup dot slash my game. Okay, so in here, this game is, by the way, multi-threaded. So there is a separate thread which is taking mouse position and updating all of these cells through which the mouse is going, and there has to be a translation layer when we are going to apply zooming in and out, and that is good. That thread will need the like manner of the camera, a camera structure. Oh, this is cool, this is cool. We got this. Okay, we have to do a few changes. Okay, change cell has to get the camera position. That is one thing that we have to change in this handle cursor, and our function which is running on a separate thread is update cell, get cell position, reset random. Yeah, okay, get cursor position and everything, takes in grid and state, get cursor position, handle cursor, get, this calls the get cursor position is mouse button down, edit mode. Here this spawns a new thread and runs this handle cursor function there on the thread, and this takes in the grid. And why is this taking the prediction grid? Yes, we will fix that in the prediction grid part later. std. No, no, no. We will send in a camera to the reference called camera. Okay, D was supposed to be capital. That is fine. Grids, camera. Yes, we will have to give in to this thing. Edit mode A, camera 2D reference. We will call it camera, and here we will say camera, take the reference to the camera. So, okay, that is good. And in grids, this function also has the camera. And then with grid I, we are calling the function. Okay, we will also give this function the camera because of, yeah, we have to do some translation. Go there, we will add, say, camera 2D reference. Camera is required and get mouse position. Yes. Uh, what was the name of the function? This one. Get screen to world to where the first thing is the position of the mouse, which is get mouse position, and the second thing is the camera. Okay, that is get mouse delta shit. Okay, I think we don't have to change the get mouse delta function. This is the only thing that we have to change. We don't have to change the get mouse delta function. Yes, we do not have to change the get mouse delta function. At least I believe so. Okay, that is handled. That is good. And uh, non. And yes, after doing this whole rebase thing, we will optimize the game, which is the main thing. Because if you look at this, this function is running on a separate thread, and this has a infinite while loop here. While we are editing the grid, this loop keeps running, and through each iteration, this is what we are doing. We are making a prediction grid, which is a 1000 by 1000 grid, or I think which is a 100 by 100 grid, and we are copying it. And this is, yes, this is copy operation, and this is not very acceptable. This is very bad, and this is going to take a lot of memory. So yeah, that is bad. We'll fix all of that. Edit mode is being called, and this will take in the camera. And what is the camera? Camera is camera 2D. Camera, that is nice. And any more errors? Okay, there are errors. Okay, we have fixed this thing. We had camera here. T grid position, which is the edit function now, so that is nice. Update update camera needs screen width and screen height, which we can add to the variables file, which is literally here. Okay. Dialog box. Delete this. And yeah, we'll define this here and copy good variables and paste this here, and here we'll say hash define hash define, remove the equal sign here also, and that is cool. So okay, we'll just fix the helper function here. Update camera is something that we have to call in update in the edit. Oh, and is this happening inside the while loop? Yes, it is happening inside the while loop. So in our current function here, we will call the update camera function and give it the camera. That is nice. Okay, what other things are related to camera? Update camera, that is done. And there is also one this thing that we can do. If we are on a word in Vim, then we can just press Shift 8, which is the star asterisk sign, and we will search for that word in the whole document. So that's cool. Change cell is being okay. Yes, we have already handled that. Begin 2D camera, render grid, and end 2D camera. Yes, these are the functions that we have to call. Okay. Then it mode begin render prediction grid and stuff. Yeah. Okay, instead of this, we will go to the camera. Yeah, we will give this to the camera, to the prediction grid. The prediction grid will handle the camera stuff. Okay. Get cursor position and okay, yes, that will also handle. Cool. Update camera. In camera, yes, begin camera. And yeah, we are at the top. Okay, so everything is handled. Everything related to the camera has been copied from this to here. Now we have to fix these bugs here. First is this one, update camera. Update camera. No matching function call to update camera because well, update camera is in here, and this is taking these functions here as input. Fix camera, init camera. Okay, and here we don't have to take these variables as a parameter because they are being given to us. They are in the variables file, so that is cool. Fix camera and shit. Update camera function is different here. Wait, is like camera.hpp not even included? Yes, it is not even included. Okay, okay. Render prediction grid. Yes, we will fix that. Let's fix that. Rendering.cpp, render prediction grid. Right here, we will say that camera 2D reference is another thing that this function takes. And here, begin texture. This is the part here. Begin 2D model 2D camera, and when we are done we will say end model 2D, and the same thing here. Begin model 2D Camera is something that you have to give to this function also. Okay. Camera 2D, a reference, not a copy. And after this, we'll say and model. Mode 2D, not model. Okay, and there doesn't seem to be any errors in this file. That is nice, and no one is calling this function. Print correct one. And yeah, that is cool. That is cool. And now the main file. Yes, there are some errors in the main file. First of all, what are these two lines? Right, and then edit mode grid. Also take this will also take in a camera, which we will copy from here, and camera is not being included here. Dot cpp redefinition of camera zoom speed. Camera dot cpp at the top. We will say if not define camera, then define camera, and here and if. That is nice. Version control maker in file. That is fine. Init camera. This function doesn't take the height and width anymore, and edit function also takes in camera, and handle run inputs also takes in the camera, and render grid also takes in the camera. That is nice. And let's see what are the other places where we had to use a camera. Take prediction grid. That is nice. We have done that. Update camera is another function that we have to call. And okay, we'll call that. Begin drawing. Why do we have to update this inside begin drawing? We can do that outside. Okay. And yes, done. Update camera, done. Take grid position with camera, done. Done. Begin 2D model, and yeah, that is handled inside the render, so that is fine. We can delete everything. Okay, do we still have some conflicts? Get status. Cannot. Change is not staged for commit. Unmerged paths. We have made changes in camera and rendering. Git add all of this. Git commit. And yeah, but before running this, let's see. Make dot slash my game if this is working or not. Not working. Scrolling off. Okay. Okay. Shit. Uh, the camera zoom is not updating, and not just that, nothing is happening. Nothing quite is happening. Hello. Is this Lazium? Nope. How did you get good at Vim motions? Just delete VS Code. You will get good at Vim. DSA नहीं होता. just do questions. And yes, also be very humble, and when you do not get when you are unable to solve even simple questions, then accept that you are unable to solve simple questions and get understand the concept which is which you are unable to get. And message got retracted somehow. Okay, shit. Shit. This is not working. What is this? What is this? Okay. We'll have to see now how things are happening. Main function is initializing a camera, makes init camera function is initializing the camera. Yes. And camera is this. Target is the center and offset is in from the center, so that makes sense. And rotation is 0 initially and zoom is 1. Okay, that is cool. And update zoom takes in the camera, then target offset, game of life. Okay, this thing. And okay, let's look at the comments. What were the specific changes made? Is this Vim and is this Vim config available somewhere? Yes. If you want to, better than using my config, which is like very bad, you can use kickstart and Vim config. This, and this is very cool. If you go to there in a .lua, it has like quite a bit of things, and this is what is mam.leader, and every command that they are using in this config, they are explaining what these things do. So vim.o.number equals to make line numbers default. Yeah, so this is much better. You can start with this and you can see what these commands mean, and yeah, that is cool. And there is also a video by the person who wrote this config. It is by this person, TJ DeVries, and you can watch this video. And yes, just look at the starting introduction. Okay, he is sad Vim is not good, then he goes to kickstart and copies the link, pastes in the terminal, and now starts new Vim, and everything happens on its own. You are installing packages using lazy, and you do have a vimrc. That is nice. You can use this. GFG is above. Yes, that is cool. What is GFG? Hello, good afternoon. Shit, I'm very stupid to know what is GFG. And okay, not main branch. What are the commits on the dev branch? Okay, we are on this commit. We are rebasing this commit, and okay, we have a new file, new separate file. And what were the things? Okay, world width and world height, minimum zoom, zoom, screen width, screen height, and screen width and screen height are not changing here, so that is fine. Screen width, screen height, they are not changing. Why would screen width and screen height even change? That makes sense. Okay, and calls grid, that is nice. World height, half width, half height, target. Okay, clamp is something that we are using here. Okay, and then init camera, initializing the camera. Okay, that is also handled correctly here in our rebase. And minimum zoom, get the minimum zoom, wheel, get mouse wheel. Yes, so this is messing up somehow. Get mouse wheel if not equal to 0, then camera dot zoom plus equals wheel into camera zoom is speed into camera dot zoom. Let's change this for testing purposes to something else. Let's say when someone, okay, before changing, let's see what is actually happening. Key up, key down, left shift, left and right for shifting. Okay, let's test the shifting things. My game, and yeah, this is not very good. You messed up big time. You messed up big time. Okay. Vector delta, get mouse delta. Get mouse delta. Get mouse delta. We have to change the delta. Okay. We need camera dot zoom. Okay, what is this doing? Is mouse. Okay, vector delta. And we are changing the target by that much. And this is happening when update camera is called. Right. Right, when update camera is called, and we have left clicked and left or right shift key. That is very genius, that is very genius, but it does not actually work. Okay, okay, there are a few things that you have to fix. First would be in our helper function, the get mouse delta. Yes, we have to divide this by camera, yes, delta dot x divided by camera dot zoom, delta dot y divided by camera dot zoom. Yeah, hopefully that will do something. Make and dot slash my game, run the game. Okay, okay, at least we are seeing only the cells through which we are going, so that is good. But yeah, the scroll wheel is messed up. The scroll wheel is messed up. The scroll wheel is messed up. Okay, we saw this line, and yeah, so everything is still consistent with this file, with the contents of this file. That is cool. I mean, where should I start doing questions as a beginner? First, I should finish all DSA and WO work, doing questions like I have done it one time. Now revise it because I know concepts of most things. Just keep doing questions, and that will help you more than anything else. Are you following any repo for this or any tutorial? Nope. We just know what game of life is and what we want, so we are working. Still didn't got what you mean by GFG above these two. Shit, I don't know what is GFG. Start with Lee. Geeks for geeks. Shit. Geeks for Geeks makes sense. GFG is Geeks for Geeks. Second mention is good. Second method is good. Otherwise, you won't understand it fully. Yeah. Keep doing questions and stuff. Don't offload the learning part to some course or something. Don't look for the best course possible or the best. That will help you. Take anything and that will help you. Okay. Here, change cell. Yes. Add camera reference. That is nice. That is nice. Take grid position is also taking screen width and height. Yeah. Yeah, which is like still compatible with what we have. Mouse world. Shit. Okay, yes, this is good. This is mouse world. X grid is equal to inside the grid. If we are inside the grid, then grid equals state. Okay. Okay, yes, we are handling that part correctly. We are seeing whenever we are like turning any cell on, it is getting turned on. So that is good. But what the hell is this? What is happening here? What is this? What is this flickering? Flickering. Something crazy is happening. I suppose it is because of the rendering function. Okay, let's make sure that we have handled everything. Take grid position. This also takes in camera. That is nice. Update camera. Takes camera. Yes, which we are giving to the camera function. That is nice. Change cell takes camera. Yes, begin 2D model. And 2D model. What was the original render function is something that I have to see. What was the original render? What was the render function like at this point? So that, yeah, so that we know when we begin the 2D camera model and when we end it. Render grid, clear background. After applying the 2D model, put everything and end. That is it. So we are clearing background and then we are also clearing background inside the render function. Okay. Color dialog box. Nope, 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 nope. Update. Help. Nope. This thing. Begin camera. Begin texture mode. Wait, who is calling the clear grid function? Shit, no one is. BG. Begin shader and 2D. Okay, that should help. But why was no one calling the clear background function? That is crazy. Begin 2D model. We can render and we can stop the prediction. Why this? Begin 2D model and background BG. Let's see, let's see, let's see. Hmm. Okay. There are some problems. Shit. Game of life. Let's see the commits again. Shit. There are crazy things happening. Okay. Added zoom padding. That is cool. That is cool. That is cool. If we just remove the camera part, wait, that one is supposed to be here. But anyway, if we remove the camera part and do the model, then everything should be okay. Like really okay. It is not. My mouse is here, but we are. Huh? Uh, okay, we are seeing stuff on that side because of the camera zoom. Laptop going to die. Let's see. Yeah. Raylib.com cheat sheet or examples. Let's see the camera things. Handle camera. Yeah. Where are we supposed to call the model function? At which point begin drawing, clear background, and then start 2D model. Then start 2D model, and inside the 2D model, put everything. Inside the 2D model, put the things that you want to change the scale. Begin drawing, clear background, and then begin 2D model camera, and then draw internally everything. Clear background, and then model 2D according to this, and mode, and all of these squares should be drawn according to that. Okay, and here clear background and begin mode 2D. This takes in the camera and end mode 2D, make start. Said we still see this thing. Begin texture happens inside camera, let's say. Okay, if we say that texture happens inside camera, that might be one thing. No, that is not the thing that you're looking. That is not it. That is not it. Though this is kind of workable, but no. That is not it. That is not it. End model 2D, begin model 2D with the camera and begin and end. Let's remove the texture for now and then we will see how it goes. Begin model 2D and end model 2D. No, let's also remove shaders for now. Begin drawing. Begin shader. Draw texture rectangle on top. Let's see. No, no. Um, no. I cannot even figure out what the problem is. The problem in CF is that it doesn't have easy tree or graph related problems, and when they have, they are 15 or 1600 rated, which are hard to solve. So I don't get to practice those top um, trees and graph. I guess you can practice trees and graph from CS. Yes, that would be nice. The game is called The Game of Life, and you can look it up, Game of Life, or if it my version was working, I would show you my version. But this is The Game of Life by Conway, Mr. John Conway, and it has some certain rules about how these structures are formed. You have a specific configuration, the state of the whole game, and depending on the state and the rules, next state is calculated, and then the next, and then the next, and that is why you see this movement which is defined by the previous state and the rules. That is the game of life, which we are trying to implement here. But some things are messed up here. And still, I do have a working version, which is backup right here. Run my game. Yeah. So this is a 2 by 2 grid where we have all of these cells, and the ones in the background, they are dead, and the ones that are light up, they are live cells. And I can go into the run mode, and now the next state is being calculated, and that is cool. And there are certain rules about what the next state should be and stuff like that. That is the game of life. And what we are going to do, trying to do right now, is we are solving a merge conflict. Game of life, backup. If we do get no pager, log 20. These are three. Shit. No pager log. Yeah. These are three commits made by my friend, and they are like very far back. The common ancestor is right here, but this is the latest commit, and I'm trying to put all of these three commits on top of this, which is called rebase in GitHub, in Git. And yeah, we are trying to just fix stuff and merge stuff together. Okay, shaders and stuff is not the problem, it seems. Wait, shit, it might be the problem. If it is clear background, begin drawing, begin 2D model, and texture. Just yeah, just remove the clear background function. Clear background. Yes, clear. We do not need clear background. Yes, that does make sense. We do not need clear background because we are drawing a lot of stuff on top of the previous stuff. That is cool. Make and run and ah, we don't see the stuff at the right place. Why? Begin to the model. Let's temporarily speaking remove the texture and the shaders. We'll figure out how to add them later. And the model and what remove texture. Okay, let's see. Nope, there is a lot of backlight somehow. This is the function which is being rendered. And there doesn't seem to be any problem with this. What is the refresh rate? Input FPS 60 might be 120 might be a bit too much. No. I cannot even zoom out. Stop scrolling. Shit, shit. I broke the game too much. Helper, no. Is the problem in the rendering part? Rendering part. This is the only part which is doing the. Yes, this is the only code which is doing the rendering. Begin 2D model, camera, and everything. If we just remove the camera part, update dialog box, and everything is still there. Begin 2D model. Yeah, stuff is happening there, which makes sense because even though we are seeing this, yeah, because even though we are seeing all of this here, the whole screen, in actuality, this is the only screen that we have. This little window, which is in which we cells are becoming alive, that is supposedly the part of the window on which we are zooming in. But why does it flicker? Why does it flicker? Why does it flicker? Which is something that does not make sense. This should not be flickering. Render grid, get shape texture rectangle. Square is a rectangle. This thing returns a rectangle, returns texture, shape, which is all of this. Texture, source, rectangles used on shades drawing. We do add the begin and end camera. Wait, maybe, when we are handling everything, the camera thing, we have to do some other kind of logic, rendering logic. Okay, it is scrolling it off. Begin 2D model with this camera and int max links. Draw rectangles. Do we have to call some other functions? No, we are calling normal functions here. Draw rectangle with a rec, draw line and everything. Camera dot target dot x. What is this draw line drawing? This is drawing a green line, which is okay. This. Okay, it does make sense. It does make sense. It does make sense. Why is this camera flickering? Yeah, this flickering, and we are also unable to change the zoom or anything. Update camera function. Update camera minimum zoom. Zoom. This is changing camera delta. Instead of wheel, we will get if key down is key down. No. Wheel equals 0, and if is key down, let's say key 1, if not function, if q and w, we are not using q and w for anything. So if q is down, not down but pressed, you will see say wheel equals 1, and otherwise if key pressed is capital W, then wheel -1. We can calibrate this. Okay, I'm pressing Q and W. Shit, Q is also for exit. That does make sense. Shit. Uh, Instead of Q, we'll have here W and I don't know, T. W and T. I am pressing P. Nothing is happening. I'm pressing W. W and T both. Maybe it is changing a bit too much. 0.1 and minus 0.1. W and T. Nope. Nothing is happening. Camera is not updating. Camera is not updating. And this is not a merge conflict thing. Check FPS. That indent, yes, indent is crazy. Two space indent. I don't know. My friends are using that. You will get issues with Apple's compiler on your Mac. Yes, for competitive programming, we have to use, or it is better to use GCC compiler because GCC has a file called bits, a bits file, and that is very helpful in competitive programming. It is like we use that file for everything in competitive programming. FPS. Let's reduce the FPS. Let's say 20. Though it should not be the problem because this was running fine before merging at 120 FPS. Yo, that thing does not even make sense now. What is this? I think camera is not getting updated. Update camera. This calls the min zoom function, which does something. The the change that I have made is I have removed all of these instances where you were passing screen width and screen height and moved them as their separate variable here. Could that be the problem? That might could be the problem. Is this okay to define stuff like this? Screen width or screen height? I think instead of this even we can add this at the top of the files. Const expression of float unexpected expected unqualified ID. Uh, eh, uh, Instead of goals, we will have goals with rows on the whole line, and it's mean height equals this thing, and uh, camera. And this is a harpoon, by the way, working very fast. Yeah, a row is the thing. There is no error here, which is nice. Constant expression. These are const expr, not expert. See? Okay, okay, this is zooming. This is zooming, and why is this 3D? Why is this 3D? We have it. That was the problem. That was the problem. That was the problem. We were not getting the screen height and the screen width properly. Somehow something was happening. But now we are okay. Now we are like happy human beings. Okay. Uh, okay. With the help of these two things, instead of this, we will get update wheel from get get wheel get mouse wheel move. Okay, and okay, get mouse wheel move, and in the rendering function before actually rendering some things begin drawing, we will say we can also add back all the texture and everything. Clear background color, BG color. Let's just copy everything. Begin drawing, and now look at this. Look at this. Look at this. Zooming and everything. We have zoom. And let me turn off. Let's go to run mode. Look at this. This is working. This is working. Like shit. This is too good. This is too good. We got zooming and stuff. We can have something running here. We can increase the speed of the thing. And then we can go anywhere else. And the thing there is still running. We can zoom out. That is good. That is good. That is good. Now we will add back the textures and everything. Yeah. We will add back the textures and everything. What does that mean? Begin drawing, clear background, and begin text. There were two functions. I forgot how to add the things. Game of life source helper function. Yes, helper render. And let me turn on the scrolling. Take grid position. Nope. Draw. Render grid. Render grid. Clear background. Spawn. Shit. No. Ah. This is the source of truth. Help rendering.cpp. So how is the texturing handled? Begin texture mode. Okay. End texture mode. Begin shader mode. We can just copy paste. Begin texture mode. Target. Texture mode is taking the target. It's literally called the target. Here, copy, go the bottom and and here fifth. Begin texture mode. Given the target. Okay, now lo and behold, if everything doesn't fall down, okay, we have this. Oh, I think we have to call the texture function inside the zoom. How is it now? Right. So this is not zooming. This has to be outside. The texture has to be over the camera. But then this thing is messed up, kind of, right? Yes. Yeah. So we'll have to fix the texture part. This because this clearly does not check out. Is there a thing such as clear texture when we begin? No. I don't know how textures work, but yeah, there should be something. Examples with textures. Texture. N patch drawing. Yes, we can also make this in Raylib if you want to select a color, make drawings. Yeah, we can also do this if you want to. Mm. Uh, yes, let's see how are they handling this thing. Set texture filter curve start path or whatever it is. Before drawing, draw texture curve, draw line, begin texture and end texture. Okay, before moving on, I would like to go to the washroom and I'll be right back in 1 minute and we'll fix the texture part then. Just for a minute. And now it's good. Texture, begin texture. Hmm. Everything else is okay. The only thing that is messing up is the texture. If we just remove this part, what do we see? Okay, why sometimes are we seeing like cells becoming alive even at places where we are not going? Shit. Yes. No. Okay, we also have to add logic that if our mouse goes out of the screen and we are still selecting something, then we won't select anything. Yeah, this zooming in and out is not working with the texture. Even removing this, like share, there is a after image. Let's run this and we will make a glider. We can zoom in to make the glider properly. Here, like this. Should I messed up the glider? Yeah, that is cool. Go to run mode, zoom out, edit mode, remove all of this. This is not being removed. I guess it is being removed, but like behind the scenes removal. Yes, we do have a glider right here. And yes, there is an after image for the glider. There is an after image for the glider. I'll have to see how textures work to fix this. Yeah, ChatGPT or how to apply textures in Raylib with camera mode 2D. How do I use camera mode 2D with the texture drawing? Yes, or we can just look at this. Yes, texture, camera, offset, get width and height, everything is high. Inside, draw texture. We are not using the draw texture or anything. We are using begin texture and stuff. Upload my texture example. We have the background. Okay, and then begin drawing, clear background, begin 2D model, draw texture inside and outside of the 2D model. I guess we have to update the way that we are using the texture. Begin mode, clear background, draw texture rectangle, and shader. This whole thing can go inside, and we will say all of this is begin texture mode, target, and let's say even this is inside the cam and texture mode, and okay, this is not zooming in or out or anything. Nothing is happening. Nothing is happening. If we remove shaders and just use the texture function, or we can give shader on top. What is the shader function? Uh, Bloom and end this end shader mode. What do we have now? Uh, yes, that is a lot of stuff. Target texture, texture dot height, white, make stuff white. Target texture dot width. Okay, we will handle. No, don't remove the model part. We will have to read about how textures work, which does make clear sense. Clear background is also something that we will have to do every time from now on. Not yeah. Yes, we will have to do. We will have to do clear background, which yes, and shader. Remove that clear background. Begin texture mode. Run, and this will run without textures and shaders and anything. And we can even zoom in to any place we want. That is cool. That is cool. And also, let me update the documentation. What is this game? This says Game of Life. Yes, this is Game of Life. And now, since we can zoom in and zoom out, I can even talk about the rules. So in Game of Life, you have a 2D grid, and yes, you have a 2D grid, and in this grid, we have cells, of course, and cells can have two states, either dead, which all of them are right now, or cells can be alive, like this. I can make different cells alive by left click. So that is cool. And if there is a cell, a dead cell, which has, let's say this is a dead cell, it has three neighbors, then this cell will become alive in the next iteration of the game. Or yeah, if a dead cell has, I think, three or four neighbors, it becomes alive. And if there is a alive cell which has three neighbors, more than three neighbors, then that cell will die in the next iteration. And that is games of the rule, or rules of the game. And according to whatever the configuration you give in to this thing, the game updates. All right, this thing updates, and you are getting next and next iterations of this thing according to the rules. So that's cool. That is pretty cool. And I can increase the rate of updating, and we can make patterns which are pretty cool. Look at this. There is one thing which we can do. This here, I think here, this, and this, and then this, and then okay, shit, I messed up. Here, let's make it here. 1, 2, 3, 1, 2, 3, 4, one here, one here, and then one here. And if we begin this, look at this. This is a fish, and this is how a fish moves. So that's cool. We have a fish which is moving, and when this fish hits the wall, it becomes a glider. So that is cool. And when a glider hits a wall, let me speed up. When a glider hits the wall, it becomes a box, which is a stable state without any changes. There is no goal of the game This is a experimental game in like theoretical physics, philosophical terms. And the thing is, the main point of the game is the rules, the basic rules are very simple, right? Anyone can understand them in like 2 minutes. So the rules of the games are very simple, but you can make very complex structures out of this thing. Like you can make spaceships and everything. Complex structures in Game of Life. And yeah, you can make like stuff, crazy stuff like this, whatever this is. You can make crazy stuff. And the whole point is, given these very basic rules, you are able to create complex things. And this might be an analogy to our actual universe. Maybe the basic theory of everything is a very simple one or two rules, and given those rules, we humans exist, which are we are complex structures, given the basic rules of our universe. Yeah, this is some stuff like that. That is cool. Okay, okay. So this is working. We can make the PR now. Get status and get and everything. Added zoom and panning is also something. Okay, and removed shaders, which I'll add in a minute, in a while. Git, we were doing rebase. Git rebase continue and git status. There is a merge conflict in the main file. Main.cpp. Let's see. This is what our head says, and the other thing says take it idle start. Show start screen. That is the only thing that has been added. Show start screen. And if we add that thing here after setting the FPS, uh, go down, remove, and shit. If we do make and start, should see, yeah, we do see a start screen and Conway's Game of Life. Press space to start. We can press space and we have started the game. That is cool. We can start the game. We can go into the run mode. That is cool. Yeah, get status, get add this, and we have a whole separate file. Yeah. Now there are a few things that we have to do. There is the main objective of the video, which was to optimize. We have to optimize. But before that, we have to add, we will put in all the stuff that we have to put in, and then we will optimize. That makes more sense. And no premature optimization, which is the cause of all evil in the world. Okay. Shaders, we have to add shaders and make prediction toggle label, which is when we are in the edit mode, we start, and when we are here, if I let go of the mouse, then we start to see what we would see if we do go forward with this configuration. And the green cells here are depicting what would happen if we do go forward with this configuration. And if we do go forward with this configuration, this is what would happen. And we can go back to the prediction mode and see the prediction. And we can go back here, and this is what we actually see. So this should be toggleable. So we can uh, start prediction or turn off the prediction. That should be toggleable. And we will add shaders, and then we will optimize the game. Get status, get and everything, get n dot git ignore my game and make files working. Yeah, cool. Git add everything, git commit, and the message is added start screen and git rebase continue dev new. We are on dev new, and if we do git uh, no pager log graph one line the last 20 commits all of the commits, then dev new is here, and this is the main commit right now, and that is cool. We can just go to the main and merge main with the dev new branch and then delete the dev new branch. Git switch main git merge dev new fast forward merge. This must say fast forward merge, that is nice, and git log everything. uh, no pager and all, and yes, that is cool. Dev new. And how to delete a branch? I think git branch capital D dev new, it is deleted. And if we do git log no pager, dev new is gone. Git push origin main. I can make a pull request now. Game of life here, contribute, open pull request, 3 commits ahead of the main thing. Okay, rebase the branch, and yeah, my friend will accept the pull request, and that will be cool. And also because of working on this game, I have some this now has a y-axis. I have pull requests, 3% pull requests. That's cool. And description, let's add a little talk description, edit description. Added zooming and panning, added zooming and panning and opening screen, had had to remove shaders. My bad. Update comment. Cool. And now let's look up how shaders work. Or let's first make the prediction system toggleable. This is cool. This is cool. Okay. Prediction system toggleable. We want to make the prediction system toggleable. From the handle expression. Initially, this should be false. The prediction system prediction is false initially speaking. Edit mode, and here if prediction, then render prediction grid, which does make sense. Else just render grid and give it the grid and the camera. And let's say if key pressed T, if is key pressed prediction, let's say key T, T, because everything is like close to your left hand. right? We have REDT. If that is the case, then toggle. So prediction equals not prediction. Make and run, enter, start. We have all of this, and we have no prediction. That is cool. And if you press T, we see prediction. Okay, this starts from the place the prediction left, not just where it left off. Share. Okay, we have to do some other things too. Get set random. Okay, what are the places that we are using the copy operator on the prediction grid? Prediction, yes. Editing equals false. Update map prediction. If prediction, only then update the prediction. If there is prediction, only then update the prediction thing. And shit, is my yeah, my camera is gone. My camera is back. That is nice. Cool. And okay, what are the functions which are taking the prediction grid? Cursor thread. Cursor thread. Yes, if prediction article. Prediction grid equals grid. I think that is all that we had to do there. So if we start, we do something of this. Right, prediction is off right now. If we toggle prediction on, it becomes on, and we can turn this off. And now if we start the prediction again, it will start from this state where we left off. So that is nice. That is nice. And also we can zoom in or zoom out. So that is kind of cool. Okay, when we are zooming in and out, that is good. But when we do not want to update the mouse positions, if shift is down, if mouse left key is clicked, and shift is not clicked. Yeah, and not is key pressed, key left shift, and not is key pressed, key not left but right shift, and do the same thing here and change this mouse left click to right click. Space to enter, start. Okay, we can zoom in and okay, that is because substitute rest with down on the whole line. Make stuff, zoom in. Yes, now it is not changing. Yeah. Yes, yes, that is cool. Whenever we are going here or there like this, when we are like changing the perspective, the center of the zoom, we are not selecting the cells on which we are clicking. So that is cool. That is cool. And we can turn on the prediction mode, turn off the prediction mode. We can go to the actual rendering run mode. How far can we zoom in? That is actually kind of cool. It looks good. Okay, that would be the make prediction toggle, and I don't see any error with this. Yeah, I don't see any errors with this. Could there be some errors? Use arrow keys to adjust speed, or yes, we do see error, and that is this. We have to fix this thing, and we have to say T for prediction mode, toggling prediction mode, and also the mouse controls. Yeah, the mouse controls. The mouse controls. We have to add all of that. Or I think since we have a opening screen, we can remove this thing completely and give all of this detail at the opening screen right here. All of the controls we can give them here. Yeah, that would be nice. We can give all of the controls here instead of having that dialog box. But that is something I would have to discuss with the people that I'm working with. Those are my friends, and they might object. So yeah, we are working in a team. Yes. So for now, I'll just update the dialog box by cleargrid common commands. I won't add the mouse controls. Yeah, I won't add the mouse controls. Space, run mode commands. Nope, just one command. I've added just one command, and that is prediction. Uh, T, not for run mode, but for start prediction. And that is nice. We'll also have to increase the height here, somewhere. Dialog box, padding, dialog PG, margin, dialog height, and dialog width. Dialog height is the thing that you have to update. Dialog height, let's make it 310, increase by 20 pixels. And we do have T to quit, but there is too much space here, so we can uh change this to, I guess, 300, and that is nice. That is nice. Toggle prediction mode, on off, and also there is this backlight which we have. That is good. I can make a commit. Why do we have a file named 3? We have changed helper rendering and variables. That is fine. Git and git commit, and the message is, what did we do? Shit. Added prediction toggle and fixed. Added prediction toggle. I think we don't have to use the and there, and fixed mm, zooming issue. Git push origin main. That is nice, and that is actually cool, right? And now what? Okay, we have made the prediction system toggle, and now shaders. Okay, this is a big thing. This is a big thing because I do not know how shaders or the texture work. Shader slash textures. So yeah, let's see how this thing works. We have done this, and then we will optimize. Now this textures. Remove stuff. Raylib.com, and we will play around with textures. Textures. Logo Raylib. That is how to get texture on. And texture is just a picture, a photo, nothing else, nothing special. And all the functions related to texture, this is for shapes. Okay, these are for shapes. You can draw pixels, like literally pixel by pixel. Draw circle, rectangle, ellipse, polygon, triangle, number of sides, yes. Draw shapes, linear, stuff like that. Textures. These are all the functions which are related to texturing. Okay, texture, and this is for how to get a photo up on the screen. Load texture, which is just an image, and draw texture. Let's just play around with this function. Right. Let's just play around with this function a little bit. For which, let's go to programming, 3D stuff, Raylib, ls, CT examples. I think I have done some texture thing. No, I have not done some texture thing. So image.cpp, that is nice. And we will have image of one piece. Let's have this. Nico. And yes, so what we will have, let's copy this same image as, or no, we will not do this. We want to download this image, copy image address and well, let's see how to data. I think data, upload file, data. I think we have to use data, data, the link and output as nika.png. Guys, how to download using curl. Ubuntu using curl, yes. O this and then the link. Okay. Curl O nika.png and then the link. It is downloading. That is cool. ls and we do have nika.png right here. That's cool. Let's do image.cpp and include Raylib.h main and image from Raylib nika load image file path in the current folder nika.png. Take up this thing and screen height would be nika.height and screen width would be nika.width. That is cool. Init window with screen width as the first thing and then screen height as the second thing and then the title. Mm, okay, and texture 2D nika texture equal load texture from image and the image is nika while Window should close, small w, and begin drawing and draw texture. Okay, first is texture, which is Nika texture. Positions, X and Y positions are 0, 0. 10, I don't know what tint does, but okay, and drawing. And here, window, close window, and return. And here we will also see if is key press key Q, then yeah, let's run this and we should see Nika, or we should not see Nika. Shit. 'Cause this is lagging. Like literally. Shit. Why is displaying a single photo taking this much space? Unfathomable. Now we are back to fine. Back into our old ways again. Draw texture 0, 0, Nika. Maybe that is a bit too much, or let's height and width might be too much, a little bit too much. So let's say instead of this, we will have a fixed height of 800 by 800, and we won't be loading image. We will have this and path is dot slash Nika.png. Okay, and what do we see? We do not see anything, and this is kind of still lagging. We don't see anything. Is this not downloaded correctly? Uh, Nika.png, and it is downloaded correctly. Locked? What does that? Shit, permission. Uh, LSA, LSL, Nika.png, and everyone can read. Okay. Chmod 777, Nika.png, SL. Anyone can do anything with Nika.png. Image address. We put it here. .png. That is the format. If we do this, we do get the image and only the image. Say copy image address. rf Nika.png. Curl out Nika.png. This thing. Luffy as Nika. In image.cpp. Okay, and yeah, we still don't see anything. What is the problem? The problem is either with Raylib or with the way that we are storing this thing. Resources slash yeah .png load texture. Texture must be loaded after window initialization, which it is being loaded after window initialization. Yes, window initialization, and then load the texture. and then draw texture, screen width divided by 2, and minus texture width divided by 2, screen height divided by 2, and texture height divided by 2, so that this thing is in the middle of the screen. That does make sense. The tint is white. Draw text. This is a texture, but shit, why don't we see image? Draw texture, Nika texture, and this is being loaded after init window. Screen width, screen height, begin drawing, and wait, even if we are not specifying the FPS, set target FPS 60. This should not have been the problem, and this is not the problem. And this is not the problem. Raw texture, begin drawing, and drawing. Not window should close. Texture, everything is fine here. Nika.png. Is a binary file. Open this, and something is wrong with the file. Luffy as okay, is yes, something is dot web p dot web p. Let's use this one. Uh, Luffy as Nika dot web p and image. Nope, that was not the problem. Maybe this format is not supported by Raylib. Copy image and well, where is based? Mac OS. Okay, we do not have paste dot web pg. Let's use some other Luffy photo. Nico. This one looks good. Hopefully this is not web. This is also web p. Save image as I don't know. Oh, stuff. Raylib examples. Yes. Nico. Replace. Shit, this is also web pg. This is PNG. This might work. Download.png. If that was the error, that was the error. Okay, that was the error. The format was not supported by Raylib. So now we can say image Nika equals, or let's do, we'll get this image in high resolution. This is in high resolution. Copy image address. And this is dot JPEG. The last one was also JPEG. Curl output and ls are m everything that has Nika anywhere or capital Nika. Everything that is dot will be. That is nice. And now, and also rm download curl output Nika dot jpg from this site. Open the current folder and we do see the preview, so that must be cool. And image dot cpp here Nika equal load image from Nika dot jpg, and the screen height is Nika dot height, and the screen width is Nika dot width. Screen width height, don't do download, load texture from image is Nika. And yes, this does work. This does work. We have everything we ever wanted. Okay, and this is not even taking a lot of CPU resources, which is like true. Yes, why would a single image take CPU resources? So that is cool. That is cool. Why are you downloading imaging from? Can you just right click and save as in browser? Yes, I can always do that. Anyone can do that, but I wanted to download in the console because why not? Testing and stuff. Okay, we saw texture, how to put an image. Then we can have this, which is rotation. Texture, get the texture, frame width, frame height. Rotation is 0. Rotation plus plus in every iteration, 60 FPS. Clear background and draw texture. Pro. Give the texture, rotation, white, and also origin. Origin would be shit. Origin is also changing if we are changing the texture. It seems origin is not changing. Origin is frame width and frame height, which is just in the at the middle of the thing. Okay, origin is the middle. Source and destination rectangle. Okay, we don't need that. We need how to give texture, like something like this, I guess. Particle blending. Wait, shit. Okay, that is cool. We can press right keys to change the speed. Shit, that is how animation works. This is just switching between different pictures in the frames. That is how animation works. That is cool. That is cool. That is like illusion in our head. We feel like this is working, like this person is running, but he's not. Spirit. Shit. We have explosion. Fog of war. Arrow keys. Okay, that is cool. Okay, These are the texture functions. Load image. Draw texture and everything. In our code base, we were okay. Yes, this there is a pull request. In code, and here the way that we are drawing textures, I will have to talk to my friend. He was doing all of this rendering. Like, what does he mean by this? What is in texture mode? Target. In texture mode, begin drawing to render texture. Render texture 2D. Load render texture. Okay, what is render texture then? Render texture. FBO for texture rendering. What is file binary output? Frame buffer object. Okay. Frame buffer object in computer graphics and game development, particularly within the openGL API. FBO stand for frame buffer object. A frame buffer object is an extension that allows the for flexible off-screen rendering, which includes rendering a scene directly into a texture, a technique called render to texture RTT. Render to texture. Okay, this is something, yes, of course, this is new. What is file buffer object and OpenGL? Buffer object, or sometimes colloquially called file buffer object, though that is not the official name, is a block of memory on GPU used to store data that OpenGL needs to render graphics. It is a fundamental mechanism for efficiently passing large amounts of data like vertex positions, colors, indices, or pixel data from your program CPU to the GPU. And what is the memory that the GPU has? VRAM, video random access video, because GPU. Okay, VRAM explained. See, yes, from Reddit. Yes, that is where we read about this from. I'm looking into buying a GPU, but I am curious on VRAM as well. So I was wondering if someone would know a more technical understanding of VRAM. A GPU is just a computer that is really good at doing the math necessary to display images. Your GPU is actually a whole separate computer within your computer. Very cool, right? Yes, it is cool. VRAM is simply where the GPU stores the data it is working with, just like DRAM. Okay, DRAM full form, dynamic random access memory, is where the CPU stores data it is working with for real. It has all necessary components of a computer, probably why it is a single most expensive component in a device. Typically, there are budget GPUs too, if you consider them MSRP, minimum selling uh, retail product, which you can just imagine of. Okay, I do get your question. GPU is great in computation. It is really powerful that it can do parallel computation with different data and magnanimous floating point calculations, which you see is as an image. Okay, I have some questions. The image is getting refreshed more than 60 times every second in a typical gaming scenario. Just imagine the power of the GPU if it had to map the image and send info that all the pixels light up beautifully and you see a new image every 70 milliseconds. That is pretty fast. Pretty faster than you think. Okay. A computer is a machine that computes. A GPU is a machine that computes. They both compute. Computers do computation. Okay. If you are playing on 1080p or 1440 monitor, 6 GB or 8 GB of VRAM is fine. On 4K, you want 8 GB minimum and 10 GB on high or higher as standard. Realistically, 4 GB is fine for 1080p. If you mind turning a few Mac M1 VRAM, how much VRAM does Mac M1 have? Does not have a dedicated VRAM, video random access memory. Instead, they use a unified memory architecture where GPU and CPU share the same pool of system memory. This means the amount of VRAM available to the GPU is dynamic and comes from the total system RAM, which is 8 GB. I have the 8 GB one based on the needed at a given time. Let's see how the GPU works. Okay, yes, the basic difference is fine between a GPU and a CPU. CPU can do heavy tasks and has fewer number of ports, but a GPU can do a lot of tasks and can only do a uh, basic, can only do mathematic operations quickly and has a lot of ports and thus it can handle a lot of parallel maths things. Let's see what ChatGPT thinks. Yes, GPU is cool. Okay, you are on the right track. Let's sharpen and expand that a bit. CPU is designed for generality and flexibility. It has a small number of power cores, typically 4 to 16 in consumer systems. Mine has 8, that is fine. That can execute a wide range of variety instructions, arithmetic, logic, branching, memory management, etc. Memory management. For memory management, we have a separate unit called MMU, but okay. Each core is optimized for low latency tasks, meaning it is good at handling one or a few complex things that depend on each other, like running your OS, handling interrupts, executing game logic, etc. A GPU, on the other hand, is built for throughput. It has hundreds or thousands of smaller, simpler cores, each capable of doing arithmetic operations very quickly, but these cores are not as flexible. They excel only when doing the same kind of operations many times in parallel. For example, adding thousands of pixel colors or multiplying large matrices in machine learning. Okay, and the CPU has DRAM, which give um, more amount of data per bit, which has less number of read pins, and GPU has VRAM, which has more read pins, let's say. You are touching on a real hardware level distinction, but let's refine GPU plus CPU plus DRAM. A CPU typically connects to a system DRAM, 4 or 5 DDR, and through a memory controller. DRAM is designed for flexibility and capacity, not extreme bandwidth. The memory bus width, the number of data lines pins is relatively narrow. For example, 64 bit bits per memory channel, and a CPU might have 2 or 4 channels in total. 64 if the computer is 64-bit, then 64-bit per channel, and each core might have a separate channel. But in a, in a channel individually, we do have 64 bits. Okay. That is plenty for general workloads, but limits how fast data can be streamed in and out compared to a GPU. The CPU's cache hierarchy, L1, L2, L3. L1 is like inside the processor itself, L2 might be inside, might be outside, and L3 sits between the main memory and the processor. And main memory is RAM. Compensates for this, it hides memory latency. What does it compensate for? That is plenty of general workload, but limits how fast data can be streamed in and out. Okay, because we don't have a lot of throughput. Happy birthday, mother or man, which is specialized for massive bandwidth. VRAM chips are connected with much wider buses, hundreds or even thousands of data lines. For instance, a modern GPU can have 384-bit or 512-bit wide memory interface. 524. Okay, if we have 4 channels in a 64-bit size channel, then we have 256 outgoing bit connections anyways. So this is not like very impressive. I think some even use uh, this one high bandwidth memory stack close to the GPU with through silicon via TSV through silicon vias, giving terabytes per second of bandwidth. Okay, that is crazy. This huge width means GPU can read and write massive chunks of data simultaneously, perfect for parallel arithmetics. Arithmetic takes tasks like rendering or AI matrix operations. So the more accurate version of your statement would be CPU connects to DRAM through narrower channels optimized for low latency and flexibility, while a GPU connects to VRAM through much wider high bandwidth interface, allowing it to read and write enormous amounts of data in parallel. That is nice. That is nice. Okay. Okay, so we have CPU, GPU. CPU has smaller number of cores and can do more flexible and more heavy tasks. But GPU has a lot of cores, but they are like purpose made for arithmetic operations, multiplication and matrix multiplication and stuff like that. And they need data to work on. CPU, the main processor, it connects to DRAM, which is dynamic RAM, random access memory, and DRAM has channels. Channels generally in a 64-bit computer are of width 64 bits. A single channel can have 2 to 4 channels in a single DRAM. That is nice, but VRAM is the thing that GPU uses, and VRAM is video random access memory. And this does not have multiple channels, it has a single highway of sorts, which can be very broad and go up to 512 bits wide. Yeah, so a GPU can read up to 512 bits per second or write 512 bits per second. That is nice. That is like their hardware. But why do we need this? Why do we need all of these multiple calculations in parallel to show stuff on the screen? Why do we need to do calculations in parallel to display stuff on the screen? Right. Uh, right. Why do we need? Like if I am telling my CPU that I want to see a circle on the screen in the middle of the screen and the color should be red, and I've also given the dimensions, then what is left to calculate? I have told explicitly what I want on the screen. So like What is there to calculate? Excellent question. Let's start with the simplest idea. A screen is just a grid of pixels. Makes sense. Even a modest full display 1920 1080 has over 2 million pixels. 2 million because that is 1920 into 1880, which would be 1920 into 1080, 2 million. That is correct. Okay. 2 million pixels. And this is pixel by pixel. This many pixels. Okay. And each pixel has three color channels: red, green, blue. Okay. So it is 6 million values that need to be computed or refreshed, ideally 60 times per second for 60 hertz. 60 hertz, that is 60 fps. Do the maths. So this many pixels and 60 frames per second, and also into 3 because we have 3 colors. Each pixel often requires multiple arithmetic operations: color blending, lighting, shading, texture lookup, anti-aliasing, etc. We are easily talking about billions of math operations per second just to render a smooth image. Now, image doing that sequentially, one pixel at a time on a CPU. That is what would happen. Even a fast CPU would crawl. That is where parallelism comes in. Here is the key idea. But why do we need to do all of this calculation when we do know what we need to show? Like if we already have the pixels of our image that we want to display on the screen, then why do we need to do all of these calculations? I guess because we might do this, right? Move the screen around somewhere, and that requires some calculation because we are not just seeing anything static. That that I guess makes sense. So the GPUs, thousands of cores can do core 1, core 2, core 3, core 4. Yes. Yes. Why this works so well? Graphics math is repetitive. Most pixels go through the same sequence of operations: texture, mapping, lighting, equations, etc. Independent calculations. You don't have to wait for one pixel's result to compute another. In So yes, independent. This is like XOR operation. Yes, independent. This is called data parallelism. Uh, okay. If we want to show an image on the screen and we already have the image file, if you already have the image file, in the image file has the pixel data that should be okay. Shit, but the image can also be not can, it is encrypted in its own, not encrypted, codec encoded, and the image is encoded in its own format, so that has to be decoded and then displayed. I think that plays a part, that should play a part. The image file has the pixel data that should be shown. The image file has the pixel data that should be shown on the screen. Then what is left to calculate? What is left to calculate if we already know the pixels? Perfect. That is a sharp and fundamental question. If we already have the pixels, let's say this or this, the pixel data is technically known. So why all of the calculations? The file, the image file is not equal to what is on the screen yet. Even if you have the image, the data inside that file is not raw list of RGBs. It is encoded, right? Compressed. JPEG is very complex. JPEG, I've heard JPEG is very complex. JPEG standard jpeg.org. I want to see the JPEG standard, JPEG 2000. What is this? The core coding system, part one, defines the core coding system. This. So where is, okay, this is the part one, I guess. Part one currently includes the following parts. Okay, JPEG 1 currently includes all of these parts. Where can I see? Specify the core coding system. Huff. This uses Huffman encoding. Okay. Documentation. Shit, I'm stupid. Documentation. They have book. They have books. Publications books. Where can I see the book? Shit, is proprietary. No, it is not proprietary. It is an open standard. So why are they asking for money? PDF. Shit. Shit. So they are asking for money for the format. Okay, anyways, back to the thing. JPEG, and so the data in the image is encoded, and that is not the raw data. I think we can see standard PNG standard. Portable network graphics. Okay, this is the whole standard. And I have heard that PNG is not that complicated. Even a caveman can do it. Portable network graphics and 81 pages. 81 pages we can maybe coders, decoders. Maybe someday we might do some stream in which we'll read the whole PNG thing and implement our own PNG format. That would be cool. That would actually be cool data representation. Or at least this data representation part. This is not even too long. This is like 4 pages. Alpha channels. And this will give us like immense understanding of how image is handled. This is cool. This is cool. This is cool. Shit. I removed channel. Okay. Yes. Here we were. That is the CPU's work, not GPU rendering, but it is the first bit of calculation that has to happen. Notice, so the first step is decoding the whole thing, which is done by CPU. Okay. Then getting the image to VRAM. One decoded, the pixel data has to be compiled into the GPU's VRAM, copied into the GPU's VRAM, because your monitor doesn't read from your SSD or RAM, it reads from your GPU's frame buffer. Shit, that is very cool. That is very cool. Frame buffer. Okay, frame buffer is different from VRAM, which is a special memory region representing what is currently displayed. Can we? That is good. That is good. That is the framework. Looks like a 2D grid of pixels. The GPU is responsible for storing the array efficiently in its memory, sending the signal to the display at the correct refresh rate 60 times per second. That is not calculation in the math sense. It is, but it is managed by GPU hardware, optional transformation, blending, scaling effects. Now, most of the time, you are not just showing the image as is. You want to resize it, rotate, blend, apply filters, animate. All of those requires per pixel arithmetic. For example, to blend two images with transparency, each pixel is computed as this. For transparency, background multiplied by alpha. Share, that is what the fourth thing in color means, alpha. Background, if alpha is 1, then background is 0, and we get stuff on the foreground. That makes sense. let's do this. Let's do this. Let's okay, shit, I want to make our own function which will take an image and it will apply a background of alpha, and background, we will just keep the background as a simple solid color. And yeah, it will be right here. Okay, what do we need? Void, do not return anything. Apply alpha float a and pixel color pointer pixels and width and in height. And what are the things that not the image, but this texture has this texture is texture, which is this format, data pixel format, type id, raylib.com, cheat sheet, draw pixel is draw pixel x position, y position, and this draw pixel using geometry can be slow, with care, use with care. Draw pixel, no, that is not what we want. We do not want that. Image draw pixel, destination image, this and color this, and given the image, okay, we can use this function to draw onto the image itself, like directly get image color. Yes, we can use this given image pointer, and we can say and this do this. Okay, set of this image pointer img foreign I equals 0, width we go from top to bottom, I smaller than x and y. X is width, I smaller than width, and I plus plus. Okay, for int j equals 0, j less than height, j plus plus. Why do we have this like twice? And now draw pixel, image draw pixel. The image is img, x position is I, y position is j. Color, let's make the user give the color. Yeah. We cannot just we have to do some calculations with alpha and get pixel. Get pixel must be a function. Get pixel structure pointer. No, structure pointer. What is the structure pointer? Get from a source pixel pointer of certain format. I think any format works out. We have to give in the format. Okay. Okay. Final. Original Get pixel color. Shit. Original. Get pixel color img, and the format is image does not work out. How can what can be a format for a specific certain format now? Get pixel color Raylib option, and let's see image. That is not how it is being used. This is wrong. Get pixel color. Set pixel color. Get pixel color source and format. Get pixel data size. Why? Pixel is one thing. Uh, how can we use format? What are the types of formats? Structures. Colors. Format. No, format is not here. To use this thing in an example. Load image. Load image colors. And then load image colors and load image colors, which is a pointer to colors. We can load image colors. And then we can give a pointer to image colors. Okay, shit, we don't have to do load image colors from texture. Load image font. We can get the image colors, but then how would we set up, change the colors, and after changing the colors, or maybe we can change the things in the, not in the image, but in the texture. Places where we see texture and pixel both. Load image from texture. No. Set shader value. Begin texture mode, end texture mode. That is cool. Pixel color. Okay. Clear background with a color. Draw pixel XY position, but this is directly on the screen. Don't want that. Draw pixel V. Draw circle, ring, pixel or color. Draw color. Sweep lines. Let's check collision. R pixel load image is image. Get image color. Uh, width and height, and also color. Generate image color. This will give us an image, and you have to give in a single color. Okay, no. Gen image gradient, gen image. All of this returns an image texture, image image, generate image from image, copy image channel, image text, G, rotate image, load image, colors, load image palette, unload image, get image colors. Get image colors gives us a single color from this location, which is something we can use. But how do we draw stuff on the screen with this? Image, draw rectangle, line, circle line. Image, draw pixel in this image. Why didn't we use? Okay, yes, we can use this function to write stuff on the image and get image color to get. Yes, makes sense. Okay, this might be too small. Orange equals get image img ing. Okay, we have the image color, and now we need to calculate values for the target color, and we will say not org but final dot b equals background color dot b color dot b, multiply this by 1 minus alpha, 1 minus a alpha into this thing plus a into org dot b, and we have to do this for uh, r g b g b, and image, draw pixel on this image at this location, draw final. Okay, I guess we are cooking. Uh, and now, after getting the image, we will apply alpha. Alpha. Let's keep the transparency at 0.5. Our image is called Nika height. Okay, let's do this after this. Height, but before that, width of the image is screen. Width, height of the image is screen height, and color, let's say red. And that is red, I guess. Uh, we do not see a lot of red. Shit, don't tell me this is all becoming integer. Yes, at the end, this is becoming integer. Yeah, that is. We should, we have to reduce the transparency. 1. Okay, this is not actually red. 0. So we should not see image at all, but why do we see this strange looking color? Red. Why do we see red if we were to use to use black here, we do see black, and if we change the transparency to 0.5, then what do we see? We do see black, and this, but black is not very nice. Let's make this, or purple, and we do not see purple. We do not see purple. Even at zero transparency, we do not see purple. Okay, so we messed up somewhere down the line, wherever that was. And yeah, this has been, yeah, share. We branched off from this line. The display pipeline never stops. Okay, GPU puts stuff on the frame buffer, I think it is called. The GPU keeps putting stuff onto the frame buffer, and the display keeps taking stuff from the frame buffer and displays it onto the display. And CPU to put stuff on the frame buffer. CPU sends data to VRAM, from where GPU picks it up and puts on the frame buffer. And yeah, we see things on the screen then. That is cool. That's cool. We got to know how GPU works now in a way. That is nice. And that would be it for today's stream. And thank you for being here. If there is anything you want to type in the chat, now would be the time. Yep, now would be the time. And that would be it. Thank you for being here. Bye.